Yeah, sorry, my I have some issue with my. There is some issue with the cam, but I will try if I can fix it.
Okay. It's ready for you or no?
Is it?
It's ready for you?
Yes.
Yeah?
Okay.
I need
Yes.
the camera.
Okay, let me try this. Wait a second. Okay, just 1 minute. Give me a minute.
Okay. Let me come, okay?
Okay, just 1 second.
Okay. Go ahead at the student. One moment. Okay. Good morning, guys. Good morning. Hello, good morning.
Hello.
Hi, good morning. ¿Cómo están, chicos? Buenos días. Good morning.
Hello, teacher.
¿Cómo están? Buenos días.
Good morning, teacher.
Good morning. Okay, guys. Today has the professor Sat, who will teacher is the science class, okay? Any concern you can say, teacher?
Yes, yes.
Yeah, is ready for you?
Yes, yes.
Okay.
Yeah, you need to.
Okay.
Yeah.
Go, please. You can say, teacher.
I'm saying you need to allow me to screen
Okay.
share.
It's ready.
Okay, thank you.
Thank you.
All right.
Thank you, guys.
So, Hello everyone. So now today we are doing three things: matrices, determinants, and probabilities. So let's start with the matrices. So a matrix is a mathematical object that is made of arrays, right? Like this. Let's say A, B, C, D. These are the arrays, and these are called the rows. These are the rows of the matrix, and these are the columns. Okay, these are the rows and these are columns. Okay, so we have rows and the columns. That's how we, and A, B, C, D, they can be any real numbers or complex numbers or any number entries. And the next thing that we when we look at here, next thing we need to know is the okay, so the next thing that we need to know is dimension of the matrix. So, okay, so to measure the dimension, what we need to do is to measure the dimension of a matrix, we need to know its number of rows and its number of columns. Let's say I have something like 1, 3, 5, 7, 9, 2, something like this. So if I want to know its dimension, I need to know how many number of rows it have. Right? So let's say this one have 2 rows, 1, 2 rows, and 1, 2, and 3 columns, right? So 2 rows and 3 columns. So we write it as 2 cross 3. So its dimension is 2 cross 3. 2 means 2 rows and columns cross R cross C. So rows cross the columns. Okay, and the elements that are inside there, let's say this one, and in any number inside there, any entries, these are the elements or entries of the matrix. Okay, so okay, now let's okay, so there, let's see. If I have a matrix which is, let's say, just 1, I have written 1. Okay, it have 1 row and 1 column. It's 1 cross 1. Let's say if I have something, let's say like 1, 2, 5, 3. This one is 2 cross 2. Right? Similarly, we can have 3 cross 3. So the matrices that have the same number of rows and the same number of columns, they are called square matrices. Square matrices. They have same rows, same number of rows, okay, and columns. Oops, sorry. Then there is some different specific types of matrices. The famous one are like this. They're called these are called the identity matrix. Identity matrix. It's represented as I, and it's 2 cross 2. Okay, so it's 2 cross 2 like that. So these are identity matrix. There is a null matrix which is like 0, 0, whose all entries are 0. That one is called a null matrix. Okay. Null matrix. It have all the entries as 0. Okay. It can also have like this one, this one. They are different. This is 1 cross 1. This is 2 cross 2. Okay, they're still the null matrix, but they are different. Then as we can do some operations with numbers, we can do some operations with the matrices as well. Okay, we usually represent some metric by a name capital letter A. Let's say A is a matrix. A is my matrix A. Okay, I'm giving them just the sub A1, B1, C1, and right. And I have a matrix, another matrix B. Yeah, that I name as the entries of this one is, let's say, A2, B2, C2, and T2. The two just A1 and 2 to just distinguish between them, that it is member of element A1 is the member of matrix A and A2 is the member of matrix B. Okay, so how we, first of all, we can see how we address any entry. Let's say I want to look there, I want to see its address. Its address is use the small aij, all right, or small entries. Okay, let's say, so that this one is the an A small entry, this one is 1 2, right? You can say A1 2. A1 2 means first row, second column. Okay, if you want to identify, like mention any element, let's say in B, I want to mention element in B, let's say this one. I give this address as B2 1 because second row, first column, B2 1, like that. And in general, when we have a general matrix, we use in general we use it like A I J, where I is row and J is equals to the number of column. Okay, so the next thing that we see is we look some operations with the matrices. Okay. So let's say we add them. Okay. Addition and subtraction, they are kind of same. Addition or subtraction. So let's say I have a matrix, just taking an example. Okay, let's say my matrix A is 1 3 7 2, and the matrix B is 2 1 5 9. So first of all, we can add them, A plus B, right? So A plus B, how we add them? We add the corresponding entries. So this number will add up with the corresponding entry in this one. So 1 plus 2, 3 plus 1, 3 and 1 will add up, and 7 plus 5, yeah, here, and then 2 plus 9. Okay, and then you can add them, combine the numbers. So 1 plus 2 is 3. 3 plus, let's say, 4, 12, and so like that. Okay, so this is our addition of matrices. Let's say just question here. Let's say I have a matrix A, which is 2 1. Okay, this is the matrix of order 1 cross 2, 1 row, 2 columns. Okay, and I have a matrix B, which is 2 3. Okay, so this is 2 cross 1, so 2 rows and 1 column. So the question is, how we will add them? Okay, so because now the entries don't correspond to each other, right? So in those scenarios, when you see the entries don't correspond to each other, you cannot add them. Okay, you cannot add them or subtract them. You can only add or subtract the matrices that have the same dimension. Okay, can only add or subtract. Okay, the matrices that have same dimension, or also the order. You can also say the order of matrix or dimensions of matrix, same order of matrix. Okay, so all right, so addition and subtraction, they are basically same. In addition, you just add them, and in subtraction, you just subtract them. Okay, the next thing is that comes to mind is the multiplication. Okay, so matrix multiplication is not as simple as the regular multiplication is. Okay? So let's say we have, again, let's take two matrices. Okay, or before we take, let me just give you, okay, let's just first explain a little more. So to multiply a matrix, what we need to look at order, look at the order or dimension. These are the same thing, same dimension of the matrices that we are multiplying. Okay, so okay, so the rule is that let's say we are multiplying A and B, right? A and B. So the rule is the number of columns of A, yeah, the number of columns of A should be equal to number of rows of B. Okay, let me give you an example. Let's say we have A equals to 2, or in general, let's say a general matrix without the numbers. Let's say I'm just having the entries. I'm just representing them. This is A1. Let's say this is. I write that with this name A11. First row, first column. A12. The first row, second column. A21. Okay, and then A22. Let's say I have this. The A22 represents second row, second column, and it's the order of this matrix is 2 cross 2. Okay, now if we have another matrix B, okay, so what we said, the number of columns of A, its column is 2. It should be equal to the number of rows of B. So we can have B11 and B12. All right. Oh, sorry, not 1, 2. That's B21, because row and then comes the column. All right. So let's multiply them. Okay, so to multiply them, what we need to do is we pick the first row. We pick a first row from here, and then we multiply it with this, like place in front of this column here and multiply it with there. All right, so like this. So let's do A, B, we are multiplying. So what we will do, okay, let's just write. So this is A11, A11. It get multiplied with B11, the first number here. A11, B11 in between. We took the next entry, which is this one, A12, and it gets multiplied with this second entry there, B21. Okay, then you add them. That's just done. All right, for the first row. Similarly, you pick the second row from there, and then you multiply with this column with the corresponding members, like so A21 and times B11, the first entry, then plus and A22 times B21. All right, so now let's just expand it a little bit more. Okay. Now let's say if I have one more row, in this, let's say the next row will be B12. Okay, sorry, next one more column in B and B22. So once we are done with this, okay, so again, look at this back, first one, the first row. First we multiplied it with this one, then we give the entry place, and then we take the first row again and we multiply it with this second one, and it will come here. So A11, A12. Oh, no, sorry. A11, B12. This one will go here. First one will go there times there. And then second one plus the second entry, which is A12. And then this second entry here, which is B22. Okay, wait a second. I think it's a question. And then we again, now we're done with this. We again now for the second row here, we pick the second row. We'll pick this second row there. See? And we multiply it with this second column here, similarly. So A21 and then times B12 and A22 with then plus in between, plus A22 and B22. Okay. Like this. There is one more thing about the matrix multiplication, that A multiplied by B, it is not same as B multiplied by A. It is because of, there is many reasons, but one of the very clear way by which you can see, let's say our matrix A is the one that we took about. Let's say that is A is a matrix which is 2 cross 2. Okay, A is 2 cross 2, and the B that we are multiplying it with is 2 cross 1. Okay. Okay, so then let's say we change it. All right. So you see the number of column and the number of rows, they are same. The column of first one is same as the rows of the second one. But now let's write it other way around. 2 cross 1 for the B, and then times it with a matrix which is A 2 cross 2. Right. So you see the number of column is 1 and the number of rows is 2. So they are not same. Number of columns is not equals to rows, but here the columns are equal to rows. So this one we can multiply. We can multiply this one. This multiplication can be done but this multiplication is not possible because the columns are not equal to the rows. So that's why we you can clearly see that A times B is not equals to B times A. It can be in some special cases, but in general rule, it's not true. It's not like other mathematics, like 2 times 3 is equals to 3 times 2. Okay, it does not work like that. So we can say that matrix multiplication is not commutative. That's the mathematical term for it. Okay, so all right, so there is the matrix identity matrix that I told you before. Let's say that we have a matrix I, identity matrix. It's 2 cross 2, I 2 cross 2 identity matrix. Right, and we take any matrix B or A, but we can give the name whatever we want. And let us give any number, 2, 3, 4, 1. Right, so let's check. It is a 2 cross 2, and this is also a 2 cross 2. So the number of columns is the same as the number of rows, right? So we can multiply them. All right, so let's try I times the B, or I cross B. Okay, we are multiplying them. Or even we can just write it I B. It means they are getting multiplied. So let's write I. So we will follow the rule that we decided. We take the first row of the first I, first matrix, okay, first row of the first matrix, and then we will multiply it with the first column of the second matrix. So 1 times 2 plus 0 times 4. Okay, again, pick the first row and multiply it with the second column. 1 times 3 plus 0 times 1. Now we comes to the second row, pick the second row and multiply it with the first column. 0 times 2 plus 1 times 4. Again, the first row, second column, 0 times 3 and 1 times 1. So let's just add them and see what we get. So 1 times 2 is 2, and plus 0 is just 2. Okay. And then 3, 1 times 3 is 3, plus 0 is just 3. And then 1 times 4 is 4, and the 0 times 2 is just 0. Similarly, 0 times 3 is 0, and 1 times 1 is 1. So you see, this is the original matrix B that we started with. So that's why it's called identity matrix. It's like a 1 in matrices. Just like if we do 2 times 1 in other numbers, we get 2, right? So this 1 is the identity because it do not change the identity of this number. Similarly, this identity matrix, it do not, when you multiply it with some matrix, it do not change its identity, right? So it remains the same. It remains unchanged. Okay, so let's move on to next one, the determinants. Determinants are also kind of related with the matrices. Determinants and the matrices, these are the tools in linear algebra that we use to solve the equations and get their solutions, right? So determinants is also a tool which is related to the matrices, right? So you can think of it as a scalar value or some number for the matrix. Let's say we have a matrix A, 2, 1, 3, 2, right? Like this. And we want to find the determinant of A. It's written as determinant, and then you can write it like this, or the other way to write it is you can put A and then put the line around it. Yeah. So we want to find this determinant. Okay, so this is a 2 cross 2 matrix, or yeah, this was a 2 cross 2 matrix. So we are doing its determinant. Okay. So for it's this rule is only for 2 cross 2 ones. You multiply this one with this 2 times 2, and then you put the minus sign, this minus sign here in the formula, and then this times this, and then 3 times 1. So 2 times 2 is 4, minus 3, that will be equals to 1. So the determinant of the matrix A is 1, right? And there is another thing about the determinants, that we can only do the determinants of square matrices. All right, let's say if someone gave you matrix like this and ask you to find its determinant, okay, and they'll say like find the determinant for this one, you cannot do this. Why? Because this is a 1 cross 2. It's not a square matrix. The number of rows and the number of columns, they are not equal. So you cannot find the determinant of this one. Right? So you can only find the determinant of the square matrices. And as we go to the next step, like 3 by 3 matrix or 4 by 4 matrix, matrix can be of any dimension, 5 by 5, 6 by 6. It gets difficult to find the determinant. So let me write the general rule. Let's look at the general rule for finding it. So the general rule is, let's say I want to find the determinant of matrix A. All right, it is minus 1 I plus j, where I and the j are the number of are the entry for the row and the column. Okay. Oh, wait, sorry. It's the sum. That's the sum for, we do all the okay, so we do the sum of all the entries, for that. Okay, so the i's are the row, like it starts from 1, right, and it goes up to like the end. All right, how many, the n is like how many rows are in it, right, or columns. So like that. So and then I plus j, a I j, and m. Let me tell you what is aij and mij. So aij is the entry, right, like a11, a12, a13, like that. Yeah, let's say this is a11. This is ij, means a12, a13, this is a21, right, a22, like that. So the aij are the entry for that place. Okay, and mij, the one that is written as mij, that is called minor of minor of a. Okay, and then ij, whatever the identity is. Okay, so like whatever entry. So let's say I have a matrix 3 by 3. Let's try to do it with an example, right? So let's say I have 1, 3, 2, 4, 1, 7, 2, 5. Okay. Okay, I want to find M12. Okay. Minor of identity 1. I want to find M 1, 2. So what you do, you go at this place in the entry. Where's this entry? First row, second column. This is it. Right? So what you do, you ignore this column and you ignore this row. You ignore the column and you ignore the row. All right. And you write, and the remaining, you just write the remaining. So what's left over here? Let's do the determinant for the remaining. So what's left? 4, 7, 4, 7, 2. All right. So like then you find the determinant of this thing. This is M1, 2. Let's say I want to find M3, 3. Okay. It will be, we will ignore the third row and third column. So we will ignore the third row and third column like this. We will ignore that and write the remaining. And then we find the determinant of this one. Okay, like 2 by 2 that we learned before. So this is the minor. So it can be for 3 by 3, it can be for 4 by 4 matrix. We can still do this. Okay, so and there is, if we have a 3 by 3, so let's say we take a 3 by 3. Just a matrix. First of all, 1, 5, 3, 2, 7, 2, 3, 0. All right, like that. We have something like this. Let's say we want to find its determinant, right? So what we need to do, we need to start from first entry. All right, we need to complete how many columns we have. All right, we can do that way. So first of all, let's start from here. So first entry is, first of all, we write -1, its power I plus j. So what is the entry for this 1, 1? It's 1 plus 1, right? And then aij, that is the first entry. This is the number. Okay, so this is, let me write I plus j. I'm writing the formula down so you can see aij, and then the thing. Okay, so now mij means the determinant of the thing, right? So what is the determinant? Like, okay, so mij will be this much, right? Ignoring the first row and the first column, like that. Okay, then we get to the next. We need to add all of them until, like, you start moving from there until the number of the number of columns end. Okay, so next one is -1, and then I is still 1, first row, second column. Okay, the entry is 5, and then time, this ignoring this row and this column, we ignore that, and left over is 2, 3, 2, 2. So just zoom out a little bit. All right, so like that. And then again, we get to the next row, oh sorry, next column, next entry. That is now this 3, 3. So now -1 power 1 plus 3. Oh, sorry, yes. So it's third column, first row. So 1 plus 3. And entry, here comes the entry here. And the entry is 3. And then times it by ignoring this row, this column. That will give us 2370. Now we just saw, now we know how to solve a 2 by 2 determinant. Yeah. This times this minus this times this. And minus 1 to the power 1 plus 1 will be 2. Minus 1 to the power 2. And then this is 1 times 7 times 2 minus 0 times 2. Okay, so now we have minus 1 to the power 3. And then 5. And then you multiply this 2 times 2 minus 3 times 2. And then again next one. Okay. Now it will be minus 1 to the power 4, 3, and then 3 times 0 minus 3 times 7. Okay. So now we can see, okay, so minus 1 to the power of even powers will make it positive. So it will be 1. 1 times 1 is just 1. And 1 times 14, because 7 times 2 is 14. 14 minus 0 is 14. Then plus, so, okay, so minus 1, its power is minus. Its power is odd. Okay, its power is minus 1 to the power odd. That is 3 power. So it will give us a minus. Okay, minus 1 times 5 times 2 cross 2 is 4. 4 minus 6. That is minus 2. 4 minus 6 is negative 2. And then plus, okay, so minus 1 to the power 4, that's a positive power, even power. So that will make it 1 as positive. Okay, so it's just 1. And then 3 times 0 is 0, minus 3 times 7 is 21. So minus 21. You now just add them. So 14 and minus times minus is positive. That will be plus 10. And plus positive times minus is negative. So 3 times 21 is minus 63. So then all we left with is to add them. So let's add them. So 24 minus 63. So that will be minus 39. So that's the determinant. The determinant of the matrix A that we had up there is just zooming out. So this matrix A, the determinant of this matrix A that we had is minus 39. And just one more thing, and there is many other things, but let's just tell one more thing and then we move on to next. Okay, so if so there is some determinant there, like that matrices whose determinant is 0. Okay, so when determinant of A, of matrix A, is 0, okay, then that matrix is called singular matrix. Singular matrix, right? Similarly, the idea that we had used here, we can extend it to 4 by 4, 5 by 5, right? Let's say when we were doing this and we get a matrix that whose determinant the M. Now here we got an M whose value is 2 cross 2 matrix. But if the original one is a 4 cross 4 here, this one is 3 cross 3, but not. So if we have 4 cross 4, then we will get 3 cross 3 matrices for the determinant of, then we will have to solve 4 determinants of 3 by 3 to get the answer for a 4 by 4 determinant. So that's a lot more complicated and will take a lot of time. So, all right. Is okay. If anyone have question, that you can ask. Okay, and then let me see if we can. Okay, there is some other some basic rules that are we can see. There is some other basic rules that we can see is, let's say we can multiply. Let's say there is a matrix A. All right. We can multiply it with a scalar number. Let's say like we can multiply it with a scalar number. So let's say we do it, we multiply it with a scalar, multiply with 2. Okay, so then it will become 2a, all right, like that. So let's say let's say 2, and then I write an A, just any example, let's say identity matrix, okay? Just for the example, all right? So how we multiply this times this, they get multiplied with every entry. The 2, it get multiplied with every entry. 2 times 1, 2 times 0, 2 times 0, 2 times 1. So this 2 gets multiplied inside with every entry. So it's 2, 0, 0, like that. All right. So this is 2 times A. Similarly, you can do 3 times A or any number times A. And let's say we want to find the determinant. All right. So the rule is for the determinant, let's say whatever, let's say we want to find the determinant of 2A, right? Which is equals to 2 times the determinant of A. All right, let me just show you. So what is the determinant of this one quickly? If I see this is 1 times 1 minus 0 for this one, right? So 2 times, and the determinant of this thing, which is 1 times 1 minus 0 times 0. And which is 2 times 1, which is just 2, right? Now let's redo the determinant of this 2A, right? This thing, this 2A. Now let's do the determinant of this one. That will be 2 times, oh wait. No, there is a, wait a second. It's not. It should be the same. Wait, let's see where's the. Oh, that will be 4. Yes, okay, that's right. That's correct. That's correct. Okay, so oh, okay, no, sorry. I think I made a mistake there. Sorry about that. No, I think I made a mistake. It should be like, okay, so like that's right. There's a mistake word. Sorry. So no, this one doesn't work. Okay, sorry. There, I think I made a mistake. All right, so like this is, we can multiply the matrices with like that. All right, so 2 times A, 3 times A, 5 times A, we can multiply the matrices. All right, so now let's just quickly move on to the last thing, probability. Oh, sorry. Probabilities. Probabilities. Probability is something, let's say the chance to happen an event, or how likely something is can happen. All right, so let's say like how likely is it it's what is the chance or what is the probability or how likely is it that like let's say tomorrow it will rain, all right? So the probability, the chance of that, the rain is the probability, like how much chances of rain are there for tomorrow. That's the probability of rain for tomorrow. So probabilities, we measure them in between 0 and 1, okay? In between okay, in between 0 to 1, all right? Let's say if there is a 100% chance to rain tomorrow, the probability is 1, all right? And let's say if there is a 0 chance for something to happen, the probability of that thing is 0. But anything is in between them is in between 0 to 1. Okay, so let me just give some. So okay, so how, let's say the formula for an event, let's say E represents the event that can happen, all right? And the probability of E means the probability of the event to happen. Okay. So the probability of some event to happen is like, let's say the chance, like how many are favorite outcomes, okay? Favorable outcome over the total number of outcomes, okay? Number of total outcomes. That's basically how we decide somehow. Okay, so let's say you flip a coin, all right? Let's say you flip a coin. So what's the probability of getting a head, right? So there is two sides in a fair coin, head and tails, right? There's a two sides for a fair coin, heads and tails. So the probability for a head, okay? Let's say I want to see the probability of head. We flip a coin, okay? Flip coin, and we want to see what's the probability of head. Okay, so how many possible outcomes are there for head? That's one. And how many are total possible outcomes? That are two, right? Head or tails, like head and tails. There's two possible outcomes, and the probability for the heads, the favorable, the one that we are looking for is 1. So it's 1 out of 2, right? So that's like very basic example to start with for the probabilities. Okay, so then let's have some other example. Let's say you are rolling, let's say we have two dice, okay, like dice cube, like this. I'm not very good with the drawing. Let me just try it again. Try if I can get it something right. All right, so let's say I have something like this, all right, two dice, and I roll them, all right? I rolled the two dice. So what are the possible outcomes if I roll the two dice? The possible outcomes are like this. The first die can have a 1 on it. And the second one can also have a 1 on it. Or it's possible the first one have a 1 and the second one have a 2. First one gets a 1 and second one gets a 3. and the first one gets a 1, second one gets a 4, first one gets a 1, second one gets a 5, and first one gets a 1 and second one gets a 6, because there is 6 sides of this dice, right? So 6 numbers on its top can be appear. Then the second one, it's 2 1 2 2. The first one is 2, second one is 3, okay, 2 4 2 5 2 6, then 3 1 3 2 3 3 3 4 3 5 3 6. Then let's have, let me have the next one, 4 1 4 2. These are the numbers that can appear on the top of, like, yeah, when you roll it, that appears on the top, on the first and the second. This is the first die, this is the second one. 4 4 4 5 4 6 5 1 5 2 5 3 5 4 5 5 5 6 6 1 6 2 6 3 6 4 6 5 6 6. So these are the total possible outcomes that can happen if you roll 2 dice at once. All right. So now you can ask, like, we can make any question. Let's say I ask you, let's say we make the question is, how many are the possible outcomes? How many are the possible outcomes when the sum, okay, when sum of both, okay, sum of both numbers that appear on the die sorry, sorry, I just have some, oh, my internet has some, okay, sorry about it, my internet was a bit disconnected, sorry. Can you hear me?
Yes.
Okay, okay, so now we have the 6 outcomes, all right, here, like 30, these are the 36 outcomes in total, right? So we were looking when the sum of both numbers is, let's say, 6, all right? When the sum of both numbers is 6, how many outcomes are like those? So what is the sum of this one, the first entry? That's 2, 1 plus 1, 2. 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. So there is the 1, its sum is 6, 1 plus 5 is, the first number on the top of first die is 1, second one is 5. So 1 plus 5 is 6. Then let's say the next one, okay, this is the one that will have the sum 6. 2 plus 4 is 6, right? Then this one will have a 6, right? Okay, and then I can see 4 plus 2 also have a 6. 5 plus 1 have a 6. Is there any other one that can give us a 6, the sum? Is there any other number pair whose sum can be 6? So there is no other number whose sum can be 6, all right? So how many were those? 1, 2, 3, 4, 5, all right? So we have 5 outcomes whose sum is 6. And how many outcomes are total in there? These are 36. If you count them, they are 36. So the probability for this event that the sum, this is my event, the sum of both numbers is 6. So the probability of this event that sum of both numbers is 6 is actually 5 over 36. Because there is 5 possible outcomes that the sum of these ones is 5. So the 6. There is 1, 2, 3, 4, 5 possible outcomes whose sum is 6 out of all the possible outcomes, which is 36.
Professor, excuse me. The student
Yes.
mark, has something to say? Mark? You have
Yes,
a
I'm here.
question?
Sorry. No, that's okay. I was counting. I was wrong.
Okay.
Yeah, thank you very much.
Thank you. Thank you, Professor. It's okay.
All right. So, but like sometimes it seems to be thing, but like you cannot always think. Let's say I ask you what is the probability that tomorrow you will find a $1 million in your house. So its probability is not 50-50. All right. You cannot say it's the 50% probability. All right. So like it depends on the event. All right. When you flip a coin, its probability is 50-50. All right. When you roll a die, so the probability depends on the possible outcomes. Right. What are the possible outcomes? Let's say if you flip two coins, right? You have 2 coins. We flip them. Let's say this is, I'm just, all right. So you have 2 coins, we flip them. So what are the possible outcomes? The possible outcomes is that first one gives us a head, second one gives us a head. Then first one gives us a head, then a tail. Then first one gives us a tail, second one gives us a head, and both tails. Right? So these are all the possible outcomes. So if I ask you what is the probability that we get both of the tails, so you look here, the possible outcomes. How many are the possible outcomes? 4. And among these 4, there's the one outcome that gives us the tail. Okay, so it's 1 out of 4, right? So basically, what you do when the things are independent, so there is 2 kind of probabilities, the independent event and like the dependent event. These were the independent event. Like you flip the first coin, it do not affect the outcome of the second coin when you flip it, right? But let's say we have a bag of chocolates, okay? Bag of chocolate. Bag of candies, let's say, right? Or bag of candy, right? So let's say there is 3 blue, 2 white, and 5 red candies, right? So I ask you, what is the probability that you need to pick 2, like let's say you pick a candy and that one is a red out of the bag. You don't see, you just pick it randomly. What is the probability that the candy you pick is the red? So how many are the red candies? 5. And how many are the total candies? 1, 3 plus 2, 5. 5 plus 5 is 10, right? So probability for the candy red, first candy to be red is 1/2. Okay. Now from the same bag, okay, you took one candy out and let's say you eat it. And then I again ask you, what is the probability for the candy to be white? The next candy that you pick is white. Okay. Now, this second event is not independent. It depends on the first event. Yes, it's the last. Okay, yes. Okay, so let's say this is the second candy. This event is the first event affect the second event, right? You eat one candy from the bag. Now there is less candies in the bag. Now there is total 9 candies in the bag. And now you are picking, the option to pick white candies is 2. So the probability for white candy in the second term is 2 out of 9. But if you would have picked the white candy in the first term, okay, probability for white candy in the first term, that would be 2 out of 10. So these events are not independent. They are dependent events. So if one event can affect the result of the second one, that's the dependent events. All right, so that's all from me. If you have any question, please ask.
No.
All clear. Thank you.
Okay. Right. Have a good day.
Thank you.
Thank you, Teacher Sad.
Welcome.
Thank you guys for your participation, and remember the next class for tomorrow, okay? Science. Thank you for the class. Bye, guys. Have a wonderful day for all of you.
Bye, teacher.
Bye, teacher.
Bye.
Thank you, guys. Thank
Bye,
you.
Miss.
Thank
Bye.
you. Bye.
Thank you.
Thank you.